Alright, so today we're going to be continuing our study of integration, and specifically we'll be looking at how do we integrate the sine and cosine functions squared. So if we go on, we have the integral of cosine squared x. Well, this is actually very simple because when we integrate the cosine squared x with respect to x, then we just use this formula. And the formula is just a half x plus a quarter sine 2x plus c, where c is just an arbitrary integration constant, which you've seen probably a million times by now. So this is it. This is the formula. So if you're ever given a question that asks you to integrate cos squared x dx, then you just sub it into this formula and you're good to go. The thing with this is it's less a method like something like integration by substitution, and it's more so just a stepping stone. So just like how you know how to integrate a regular cosine or a regular sine function, and you're just asked to do that as part of a question, this is the sort of thing that you'll just be asked to do. You won't so much have to, this won't be the be all and end all of a question. It's more so this is just a stepping stone to get the result that you really want. But it's still really useful to know, and it's a relatively simple formula for what you have to do. So moving on to an example, we now have to integrate this as a definite integral. So what we're going to do is we're going to start by just splitting it up, and then we'll deal with the definite integral part. So if I want to just integrate this, then what I'm going to get is I'm going to get just basically what I'd get from the formula. So it'd just be half x plus a quarter sine 2x. Now, importantly, because this is a definite integral, I'm not going to include the plus c, because what I'm going to do is I'm going to just define the boundary conditions, and then we're going to integrate between those boundary conditions. So from here, it's just like you would do any other definite integral question. After you've integrated the inside of the brackets, you just take the higher boundary minus the lower boundary. And we're going to do exactly that. And it's going to come out just as easy. So it's going to be a half times pi on 8 plus a quarter sine 2 times pi on 8 brackets. And that's going to be minus bracket half times 0 plus a quarter sine 2 times 0 in brackets. And so what we're going to do from here is we have to recognize that a half times 0 is just 0, and sine of 0 is also going to be 0. So a quarter times 0 is going to be 0. So this entire subtraction inside the entire brackets that we're subtracting by just disappears because it's going to be 0. But now looking at this side, what we're going to get is that a half times pi on 8 is going to be pi on 16. You should be able to do that relatively easily. And then 2 times pi on 8 is going to be pi on 4. Now we know that pi on 4 is the same as 45 degrees, and sine of 45 degrees is 1 on root 2. So this is going to become a quarter times 1 on root 2. And so it's at this stage that we can just simplify this a little bit more, and we can go pi on 16 plus 1 on 4 root 2. Now we can simplify this a little bit further if we were to rationalize the denominator and then combine the two fractions. But I'd say that at this stage this is good enough because this is it's a relatively nasty expression, really. And even if we simplify it into the one fraction, it's still going to be a relatively nasty expression. But that gives us an idea of the exact value. And if you wanted to do, say, to 3 decimal places or 4 decimal places, you could easily put that into your calculator and then do it. But no, that's essentially how we use those formulas. So we just integrate using the formula up here, and then we just solve it like it's a definite integral, and it all works out as we would expect. And we get a nice single number answer. In this case, it's a little bit messy because we've got a pi and a third in there as well. Now, we've looked at when we're integrating cosine squared, but what about when we integrate sine squared? So when we integrate sine squared, we actually get very much the same result, as this formula is identical to the cosine formula, except this is negative. But when we use cosine, that's going to be positive. So the only difference between the two formulas is that this sign, when we have cosine, it's positive. When we have sine, it's going to be negative. So they're actually very similar formulas. And as long as you know one, as long as you definitely know one, you're going to be able to figure out the other one, because you just know you switch that middle sign and then you're good. And again, we have the plus c. Obviously, that sign doesn't change because it's just a constant. So, and we don't even know what the constant is, so it could be positive or negative. So we just have to change this sign here, and nothing else changes. We still use sine for both of them. That's really important to know. Doesn't matter whether we're using cosine or sine, we're using sine 2x. We're not using cosine 2x at any point. So as long as you know this formula, you can use it the exact same way we just used the cosine formula, and you can use it in the exact same way and get the same sort of results when you're using sine squared rather than cosine squared. So that's not too bad. And now we don't actually have one of these for tan squared, so you only have to know the two. But when we have cos squared nx and sine squared nx identities, so basically we use these two identities, that cos squared nx is equal to this and sine squared nx is equal to that, where n is just an arbitrary constant. So this might be something like cos squared 4x rather than just cos squared x, which is what we have been using. We might be asked to do a harder problem that involves this 4x. So what we'd have to do then is we would have to rearrange the cos squared 4x into something more like this. So in that case, it would be a half outside of 1 plus cos 2 brackets 4x, brackets around those. So at that stage, well, then we integrate this new expression, which, as you can see, it doesn't involve any squares. So it's actually a much easier expression to integrate. So let's go over an example of us doing that. So if we want to find the integral of sine squared 9x dx, what we're going to do is we're going to use those same expressions that we just learnt. And so we're going to take sine squared 9x dx, and we're going to say that this is now equal to, after we rearrange it, it's going to be half bracket 1 minus cos, and the formula says it's 2nx, but in this case our n is 9, so it's going to be 2 times 9 times x dx. Now, this is for basic integration, so we can pull this half, which is multiplying by the whole expression, we can pull that out the front because that's not going to change with x. So we're going to get a half integral 1 minus cos, and 2 times 9 is 18, so it's going to be 18 times x dx. So from here, it's just basic integration. We're not going to worry about any of the previous expressions we learned involving sine and cosine squared, because those only work when we don't have this n term here, which in this case is 9. So now this is going to become a half outside of the integral of 1 with respect to x, it's just x, minus, now when we integrate cosine with respect to x, what we're going to do is get sine, and it's going to be, we're going to bring the derivative of the inside, and we're going to divide it. So that's going to be 1 over the derivative of the inside, which is 18, sine 18x, bracket, bracket, bracket. And I'm going to plus c at the end, because this is an indefinite integral, and the reason I put it at the end is because it doesn't matter if we multiply by half or not, we don't know what that constant is to begin with. So now just bringing in this half, what we're going to get is a final answer of a half x minus 1 over 36 sine 18x plus c. And that's your final answer. So when you have an n term involved, you have to use those simplification formulas for sine squared nx and cos squared nx, and then you just integrate the result, which is from here. So we just integrate this, which is really easy because it's just going to involve a 1 and the basic sine and cosine ratios, which you should be able to integrate very comfortably by now. But if we've got sine squared or cos squared and there is no n term, so it's just sine squared x or cos squared x, then what we're going to be doing then is use those previous formulas we learned on the other slides And at that stage, it's just plug and play. You just plug it into the formulas and then you can use the integral. And it's no harder than that. So I hope this lesson was helpful. I hope to see you guys in the next one.